Welcome back. Right now, what we're going to look at is how to actually find an arc length of a circle given a central angle. And we know we're going to be able to know what to do if the central angle is in degrees versus radians. So there's basically two formulas that we have to choose in either case. And you're more than welcome to put these in your formula book so you can have these for future assessments. So let's start with a couple circles here. Okay. So the one on the left is going to be in terms of degrees with an arc length S and a radius. The one on the right is going to be in terms of theta, which is in radians. So the arc length is still S for either one. So that length is still S for both the arc lengths. And we still have a radius for both of them as well. The only thing different is one's in radians, this one's in radians, and this one's in degrees. They're just two different units. So if a circle is in degrees, so if the central angle is degrees, we use this formula. S, the arc length, is equal to N, which is the central angle, over 360 degrees, that's 2N degrees, times 2 pi r, which is just the circumference of the circle. So let's just note that. That is the circumference of the circle. Circumference of the circle. And the left is just a ratio of the central angle over the total angle of the circle. That's just a ratio of the central angle over the degrees in the circle. Okay, so that's our first formula. The next idea is if the central angle is given to you in radians. I'm just going to put RAD for radians. So in this case, it's a little easier. We just do theta times the radius. So you actually want to have it in radians. So remember, theta is just your central angle, and r is going to be given to you. So it's just the arc length is theta times the radius. And if we look at this formula, you should be able to derive other formulas from this formula, and not just now, but in the future, it's good to do that. So if I have theta times r, if I wanted to solve for, let's say, theta, you can divide both sides by r, and s over r will give you theta, and you can do the same thing for r. If you wanted to divide both sides by theta, it would be s over theta, which is the arc length over theta, will give you r. So those are our two main formulas we're going to use. Let's look at one in degrees and one in radians. So here's our circle. All right, so we have lots of angles here, and P is the center. All right, so I have D, C, B, and A. This is 73 degrees. That's 104 degrees. This one in here is 43 degrees. And the radius, let's use a different color, is 4. So this is the radius, and r equals 4. All right, so first of all, let's figure out what this measure of AD is, and it's not drawn to scale, so it's not going to be 180 degrees here. It's just not drawn to scale. It looks like it's 180 degrees, but let's just do that calculation. So all we have to do to find the measure of AD is to the total length of the circle in degrees is 360 degrees minus those central angles given to us, minus 104, minus 73, and minus 43. So we'll get the measure of AD equals 140 degrees. All right, so not quite 180. All right, so that's going to be the measure of AD. Now, the reason why we're finding the measure of AD, because we want the length of AD. So that's what really, so we need the measure of the arc length to find the length of the arc. And remember, the arc length, if it's through the central angle, APD will also be 140 degrees. We saw that in the last video. So let's find that arc length given our formula for degrees. So it's S n over 360 times 2 pi r. N we found was 140 because that was the arc length that we found for AD in the last slide. Okay, so that was what we found then. Just erase all that. Okay, so that's where we got the 140 from. So 360 on the bottom. The radius was given to us, and we know what pi is. Pi is just 3.14, but we can keep it in terms of pi, and r was 4. So we just have to simplify this up a little bit. And in the end, we'll get 28 over 9 times pi is the length of AD. Okay, so that's not too bad. We know how to find that. Let's look at now one in radians. So we're given this circle here. That's H, J, K, and Q is in the center. We're given the central angle in radians, which is 3 over 4 pi. This is given to us as 1 over 3 pi in radians. And we know that this is 5, r is 5. Okay, so let's figure out what the length JK is. The first thing we're going to do is what's the length of JK. Okay, so let's just use our formula here. So we know the formula in radians is theta times r. So I just want the S of JK. Theta is of JK. From our diagram, this is JK, so 3/4 pi is theta, 3/4 pi, and r is 5. So here we can just multiply the fractions here. 3 times pi times 5 is 15 pi over 4. I guess we can make them all fractions. 4 times 1 is 4. So that arc length is 15 pi over 4. And let's just figure out a little more complicated part of it. Let's figure out what HK is given the same values. So remember that one was 3 pi over 4 . Okay, so that was 3 pi over 4. That one was 1/3 pi. Okay, so we want to figure out this length S here, so we'll do it in a different color. Let's figure out what that length is, S, which is the HK. So we need to find the central angle of HK. So we want to measure HK. It's unknown. So we know in terms of radians, there's 2 pi radians in a circle. So to figure out the missing value of theta, we just got to do 2 pi because there's 2 pi total radians in the circle minus 3 pi over 4. That's this one here. Minus 1/3 pi, and we'll get our value. And that's 1/3 pi is over here, that one. So we just need to do a common denominator of 12. So we can multiply this by 12. Multiply that by 3, by 3, by 4, and by 4. So that'll be 24 pi over 12 minus 9 pi over 12 and minus 4 pi over 12. All right, so on the next slide, we'll do that calculation. And that should be 11 pi over 12. Okay, so that's the measure of that central angle of HK. So now we can just plug that in the formula. S equals theta times R. So we found that angle is 11 pi over 12 times the radius, which was 5. So we're going to get 55 pi over 12. And that's the length, that's the arc length S we're finding there. Okay, so practice this a little bit. If you have any questions, please email me and I'll show you some more examples.